Okay, cool. Hey, everybody. I guess I'll just go ahead and get started while everybody settles in. Thank you so much for joining me today. This is my first time in Singapore. You guys have a beautiful country. I have been eating myself silly. So if I start getting a little lethargic on stage or something like that, just come up and poke me. We'll be fine. So today what we're going to do is we're going to talk about Lambda, step functions, and Datadog, a Symphony. Basically, we're going to go through, make sure everybody's on the same page with some basic Lambda stuff. We're going to go through step functions, make sure everybody's on the same page with some core concepts. And then we'll talk a little bit about monitoring. Okay, cool. So, who am I? Well, I am Alex Poe. My name's Alex Poe. The slide's not going yet, but I, in a past, darker, former life, it was a little sad, used to be a lawyer. But I made, I think, a pretty good life decision here, and now I am the lead solutions engineer for APAC for a company called Datadog. You can reach out to me. Here we go. You can reach out to me at Alex T. Poe if you have any questions about this particular presentation, about Datadog, about me, about life in general. I'm always open for a chat, so feel free to reach out by Twitter or by email. Okay, cool. Who's Datadog? Well, Datadog is a SaaS-based monitoring company. So we do infrastructure monitoring. We do application performance monitoring. We do log analytics. And we have this great open source agent. So if you actually want to check us out online on GitHub, you can see how we do what we're doing. With this agent, we pull in trillions. And I'm talking trillions of data points a day. So if that sounds interesting to you, those kind of problems, either ingesting all those data points or visualizing all those data points or storing all of those data points or just doing cool stuff with that data, feel free to reach out to me. We're hiring, so definitely hit me up. Okay, let's go ahead and get started here. What is Lambda? Okay, Lambda. What's Lambda? Is Lambda serverless architecture? Now that kind of gets people riled up. So Lambda in and of itself, by itself, is not serverless architecture. Serverless architecture, pretty big. There's a lot of components. So Lambda by itself is not serverless architecture, but it's a very key component. Okay, well, is Lambda serverless? Another thing that gets some people riled up, they say, wait, it has to run somewhere, right? It's going to do something somewhere. And yeah, that's true, it does run somewhere. But it's serverless as far as you're concerned. So you don't have to worry about that anymore. That's what AWS does. It takes care of it. And with that serverlessness comes some great benefits. You don't have to pay for idle anymore, right? That's pretty cool. So let's say you have this process. It's maybe a 30-second process, very key process, though. And let's say you run 20 of them, each on a separate instance, because you need that, right? In a month, maybe you run 300 minutes. That's a lot of minutes on idle. That's just sitting there. That's wasted. And nobody really likes paying for nothing. If you do, talk to me and we can work something out. But you don't pay for idle anymore. You just pay for what you use when you use it. Now, you might be saying, okay, well, I don't have that kind of process. I don't have to really worry about idle. Well, you're lucky, A. And B, should you still use it? Well, a lot of companies still do use it because of how scalable it is. No longer do you have to say, okay, tomorrow, I'm going to have to provision 20 more EC2s, 50 more EC2s because this is going to happen. No, instead, AWS does that for you. You just go by execution. Now, technically, there is 1,000 concurrent executions as the default limit, but that's something you can pretty easily bump just by reaching out to AWS. So what is Lambda actually? Well, Lambda itself is a function as a service. So with that, you can write these functions with Node, Java, Go, Python, C#, all of those. Okay, so I'd like to show this chart right here because it kind of shows where we were, and it takes us all the way to where we are now. So we started off with physical boxes, right? And that was your classic data center. You bought this box, you plugged it in, you plugged in the cooling, and now you have a pet. Congratulations, you have this pet that you have to keep, healthy. You have to fix it when it's broken, and that's kind of a pain. But next we moved on to virtual machines on physical boxes. And that's when it got a little bit easier to really take advantage of resources, to really optimize. But we still had to, worry about them a little bit. Next, we moved to AWS instances. So cloud providers realized, hey, we have these big boxes. Why don't we just rent out virtual machines to people? So that was great because now we don't have to worry about the physical aspect anymore, right? But you still had to kind of worry about making sure you're making the most of those resources. Then we moved to containers with the rise of Docker, Kubernetes orchestration systems. That really, though, just kind of made the unit smaller. Made it a little easier to optimize, but you still had that worry. And now we're here today with Lambda, right? The new hot thing, so hip, so with it. We have that now, and now you don't really have to worry about it anymore. You don't have to worry about optimizing. You just kind of run your function. Sure, there's some things that you have to worry about here and there, but you don't have to worry about optimizing the entire machine anymore. Now, the issue with this slide right here is it kind of equates an EC2 with a Lambda. So one EC2 equals one Lambda. And that's not true. So that's not quite an apples-to-apples comparison that you can make. And you also can't say that one AWS Lambda is an application. Because, newsflash, I don't know if you guys knew this, but applications, they tend to be a little bit complicated. And Lambdas should respect the single responsibility principles. And some of you guys are like, wait, I haven't taken a CS class in a while. Why are you yelling vocab words at me? The single responsibility principle is it just means every module, every class, every function should follow, should be responsible for one thing. And that's what Lambdas should do as well. So in reality, it should probably look a little bit like that. Thousands of Lambdas, tons of Lambdas, right, equals one EC2. So if you already have an application running on an EC2, yes, it might be a little bit difficult to port over. But once you do port that over, you get those benefits. Zero idle. You don't have to pay for that anymore. You have scalability. So it might be something worth thinking about. OK, great. So we can create tons of serverless functions, right? Thousands of serverless functions. Great. OK. What's the issue? How do we organize them? How do we say, OK, Lambda 1, do this, and then go to Lambda 2? And then after Lambda 2 runs, take that output and go to Lambda 3. Well, before step functions, we had plenty of things that acted as traffic cops. You could use an event stream, so Kinesis. You could use a messaging queue, so SQS. You could even use a database, DynamoDB. And what I mean by traffic cop is just something that says, hey, Lambda, I've got some work for you. Here you go, and hands it off. Lots of great examples out there. One of the best that I've seen is actually Nordstrom's Hello Retail. So if you go online, you can actually go to GitHub right here. You can take a tutorial and actually build this thing out. Looks pretty cool. Nice diagram right there. But this is a great example of Kinesis, so using an event stream with Lambda. And this kind of automated things where it would register photographers with product managers, photographs, things like that. But as I mentioned before, it also gave us this really cool looking diagram, which is great because I can't draw diagrams. But in reality, when you have all of these Lambdas sitting there, when you're trying to make them work together, in reality, what you might see is something like this. And that's not pretty. That's just a list of Lambdas. How are you going to be able to say, OK, Lambda 1, you're going to go to Lambda 4 after this, and then Lambda 4, 2, 3, 5. It's really difficult. It's almost impossible. So what do? Well, that's where step functions come in. You get this pretty little graph. Like I said, I'm terrible at drawing diagrams. Generally looks like a 1-year-old trying to draw out a solar system. So this is helpful for me. OK, so what's a step function? Well, a step function is a state machine. OK, cool. What's a state machine? Well, a lot of people have different definitions for this, but we'll think of it in this case like an event-driven workflow. Now, some of your ears might have perked up there, and you might have said, OK, you just said workflow. Amazon literally has something called simple workflow service here. SWF, what about that? What if I'm using that? Well, there are some things in step functions that just aren't possible, or in workflows that aren't possible yet. So SWF, you can get more complex. You can get longer processes going. So if you rely on those things, continue to go ahead and use SWF. It's not going away. It's going to stay. But if you're just starting out, you might want to think about using these step functions. Okay, so we're here, step functions. Let's go over some core concepts and just make sure everybody's on the same page. So step functions are state machines, covered. State machines have states. That's a very important part of state machines. So what we have here is we have a task, choice, succeed, fail. We have our pass, wait, and parallel. Those are the states that you are offered. Now, every time a step function runs, that's an execution. And every time it moves between states is a transition. You define the state machine with the Amazon states language. Now, don't freak out. It's not too crazy. It's really JSON-ish, JSON-esque, I guess you could describe it as. And then you can also push that to the UI, and a nice diagram will be based on that picture, on that structure. Okay, so let's go ahead and walk through these states, because these are the important things, right? First thing we'll go through is a task. So this is an example of a task. This step function is not very useful. We're just running a task and ending. That's it. But it's a good way for you to go ahead and see how Amazon states language looks and how this thing might be organized. So what you have here is you have a comment, and then you have this important part, start at. So we're going to start at the task. And then you have states, and you're going to list the states out. So you have the type, you have the task, and then type, task. And then you have a resource, which is an ARN pointing to a Lambda. Now, it doesn't have to be a Lambda. It could be an activity running on an EC2, just polling the step function, saying, hey, do you have work for me? Do you have work for me? But in this case, we're going to go ahead and use a Lambda. OK, then we end. Next, we're going to go ahead and move to choice, which is exactly what it sounds like. This is a choice between 1, 2, 3, however many things. So as you can see, we have type choice. And what's happening here is that task is outputting a variable. In this case, it's going to be a foo variable. So choice will take that as the input, and it will say, OK, if foo is 1, we're going to go to first task. If foo is 2, we're going to move to the second task. And it'll go based on what's actually output from task. Next, we have succeed, fail. So nothing wrong with ending your step function with a task. Nothing wrong with that. But it's nice to have a succeed, fail at the end, because you'll get a general overview on whether or not your step functions are succeeding or failing. So you can see that's what we're doing here. We have is positive, is it positive? And if it's positive, we're going to move to succeed. Cool. If it's negative, we're going to go to type fail, and then you can add some more language there. So you can add error language, you can add in a cause right here. And these also show up under states as CloudWatch metrics, so you can go ahead and graph those as well. Next, we have a pass. So what does pass do? Pass just simply passes through a state to the next task. Why might you want that, you might ask? Well, a couple reasons. One, maybe you are building out your step function. You know that you need 10 steps, but you don't really have the functions written yet. Well, a pass can serve as a great holder right here, where you can write that pass and kind of pass through what you know you need. Another thing you can do here is you can use it as while you're troubleshooting. So maybe you're getting an unexpected output. What you can do is you can set up a pass right there and change that output to what you need while you're troubleshooting. And then finally, you can inject additional information, which is what we're doing here. So maybe you get to a certain point in your step function and you just want to know more, or you want to put in more. And that's what we've done. We have that pass, and we're just adding in a result and a result path here. So that's pass. Next, we have wait, which is, once again, exactly what it sounds like. We're just going to wait for a little bit. Now, I'm sure a lot of you have used Lambdas, and you know that one of the big things that you can't do is go above 5 minutes, right? 5 minutes, that's it. If you go above that, it's too bad. What you can do with a wait here, though, is you can execute the Lambda and then just set the wait. So you don't have to, and you don't pay for the wait either while you're waiting. So you just, boom, wait, and you can wait for a timestamp, or you can wait for a specific amount of time. So you can wait for a day, 2 days, a week, a month. I believe you can even wait up to a year. So next thing we have here is a parallel, and this is the last one. A parallel really just lets you run 2, 3, 4, however many branches side by side, and when they all finish, they're going to come back together and run the next step. And so that's what you can see what we're doing here. We have your wait, and then it's going to go to a task. And then on the right side, we have pass, and then we're just going to go to visualize. Only once those two are finished are we going to get back to the final state. All right, so we just went through the states. That's great, but maybe you want to see them in an actual sort of demo type thing. So we're going to walk through this and just kind of see these states in actual use. So what this is this is a demo one of my colleagues built, Matt Williams. He built this using Lambda step functions. And it was a website that live blogged his session. So he had a Raspberry Pi over here. It would take a picture of his slide, send it to a third party, which would say, okay, yeah, that's probably slide 56. And then it would update his website with the notes. So we're going to focus mainly on the one on the left here. And we'll walk through that step by step. But first of all, let's see how we actually built out those step functions. So many ways to do this. You can, for example, use the console. Could work. But you got to build out the step function. Then you have to go to Lambdas, and you got to build out all the Lambdas. And you got to go to DynamoDB, build out the DynamoDB, build the code build, code commit. All of these are separate steps, right? All of these are separate steps, and you have to do that all in the console. It could get a little tedious. So instead, what you can do is you can use serverless, which is what Matt did. So with serverless, you do it all at one time. You can define everything in a single file. You have your IAM role statements, your Lambda function handlers, your triggers, step function states, CloudFormation for everything else, like code build, code commit, DynamoDB, S3. All of that can be done through serverless framework. So you have one file, really, one file to rule them all. And so from here, let's take a look at what serverless actually looks like. Okay, so we have serverless right here. You have the name, of course, a couple plugins. You have pseudo parameters for CloudFormation variables, step functions, which are pretty important to this demo. You want those. So you have step functions, Webpack, and then you have some environment variables as well. So next we go ahead and move on to the provider here. So yeah, this works with a bunch of different cloud providers. We chose AWS because AWS is awesome. Did good? Okay, cool. So we have AWS here. We have your service. You have your IAM role statements here as well. This is just a snippet. I just wanted to show you kind of what we're doing here. This snippet actually shows what you want to be able to do with the IAMs. So you want to be able to start an execution of the state machine. That's the first one. And then you want to check, be able to check code commit and check the differences between commits on the second one. And then finally, we're going to build out our Lambda functions here. So you have a function section. You'll have a handler.build for build site, what changed for handler what changed, start step function. And actually, as you can see here, start step function is waiting for an event. Now, a lot of demos you'll see will have something like an S3 trigger the Lambda. In this case, we're waiting for SNS. We're waiting for a notification. And then we're going to finally build out our step function. So this is what it looks like. You can build out a step function right here. You can see it's very similar, actually, to Amazon States language. You have your definition with the start at, your states list, where you have your states, what changed, your task, and your resource, and your next. So what's actually happening here? Well, for the demo, Matt decided to commit everything to code commits, which is essentially GitHub on AWS. And as soon as something committed to master, that would trigger an SNS, which would come through and trigger Lambda, start step function, which would in turn trigger the step function. So that's what it looks like in the serverless YAML, and that's what it actually is going to do. This is the pseudocode. What it's going to do, it's going to get the step function ARN. It's going to take the SNS details from the notification that actually triggered it, and then it's going to start that step function execution. Okay, the moment you all have been waiting for. We're finally here. We made it to the step function. So let's go over kind of just an overview of what this is going to do, and then we'll hop into each step individually. So first we have, we're going to go to what changed, and what that's going to do is going to take the input of the Lambda that kickstarted the step function. It's going to take that input, check to see what changed. If that change was Docker related, we're going to move to build Docker. And we're going to wait for that, we're going to build that Docker image, we're going to wait for that image to build, we're going to check if it's actually built, and if it's built, we'll go to build site. If not, we're going to move back up to wait for Docker build. And then build site's going to do the same thing. We're going to build the site, wait for the build, check if it's done, and if it's done, we're going to send an SMS. So let's hop through these actual states. So this is where you're going to be able to see what sort of thing you're getting with these inputs and outputs and how you're going to manage this entire flow and what makes step functions so great, because you can actually hold state here. So we have what changed. What changed is taking this input from start step function that actually kicked off the step function here. So it's going to get the SNS message ID, the commit ID, and the branch. And this is what it looks like within the YAML file. Task, which is showing an ARN to a Lambda. Next, we're going to go to build Docker or not. You can actually see we have a retry here. And that's pretty great, because I'm sure a lot of you have tried playing around with Lambda. You sometimes have to get pretty creative with your errors, with your error catching. Here, though, you can set kind of a blanket, unknown states, all, and then retry every 3 seconds for 4 times. So it's nice to have this kind of blanket statement right here where you can catch everything. Of course, you can still reroute, do very specific catches, be more custom, but it's nice to have something that's a little bit easier to use here. So what changed is going to get this commit that triggered the step function. It's going to get the previous commit. It's going to see what the difference is, and then it's going to output a variable called hasDocker. And if it's Docker related, it's going to return hasDocker true. If it's not, it's going to do hasDocker false. Which brings us to build Docker or not. Which, yep, sounds like a choice. It is a choice. So you can see here, though, we've outputted that hasDocker true. And now we're going to bring that in on build Docker or not as an input. So you can see it's true. It's a choice right here. That's what we're going to go with. hasDocker true, we're going to move to build Docker. If it's hasDocker false, we're going to go to build site. So we go to build Docker. And build Docker is just another task here. As you can see, another ARN. And next we're going to go to wait for Docker build. And all build Docker does, it just starts the code build for the Docker image. So next we go to wait for Docker build, and we wait. That's what we do here. We wait for 20 seconds. Why 20 seconds? Well, the Docker image takes about 3 minutes to build. You don't want to have something like 2.5 minutes, because what if it takes 2 minutes and 31 seconds? Well, now you have to wait another 2.5 minutes. You don't want something like 1 second, though, because you're paying for Lambda executions. You're paying for transitions, so you don't want to be hitting those all the time. You want something efficient right in between. We chose 20 seconds. So next we move to is the container built, which is another task on another Lambda. And you just take, all it does here is it just gets the build from code build and sees if it's done. And then it's going to export or output another variable. It's going to output container build done, true or false. If it's true, great, we'll move to build site. If it's false, we're just going to go ahead and move back to that wait loop. And that's what that looks like right here. Now, I'm not going to go through build site because it's the same loop. Build the site, wait for a little bit, see if it's done. So essentially, we just went through that. We went through that step function. That was it. So let's go through this one more time, big picture, but this time let's go through and figure out whether or not everything followed the single responsibility principle, because that's what we're supposed to be doing. Every step, every Lambda is supposed to do that. So what changed? All it did was see what changed and spat out a variable. Build Docker or not? Simple choice. Which one do we do next? Build Docker, just use code build. Wait for Docker build, waited for 20 seconds. Is the container built? Check to see if it was done. Output a variable. Container built or not? Simple choice. So all of these are responsible for one small thing. And I'm sure a lot of you out there were just like, okay, hey, look, that could have been built in one function, really. Maybe 2. But you don't want that. Why don't you want that? That's going to make it really difficult to figure out where things are going wrong, if they're going wrong, what's actually erroring out, where the bottlenecks are. You can switch things out very easily here now between the different steps. Which brings me to my next question here. How are you going to actually monitor that? How are you going to figure out where these bottlenecks are happening or what's happening? Well, interesting question for Datadog, because we use an agent. And as we know now, Lambda is serverless. Step functions are serverless. So we can't put an agent on it. What else can we do? You can use CloudWatch metrics, yeah, but they come at 1 minute granularity, and if you have 500 errors in a minute, say, that's going to be split into histograms. You want something a little bit more than that. You could use a provider, framework of a provider, but that might slow down your Lambdas. I don't know if the provider can handle it. So you want something asynchronous. So in this case, Datadog chose to use logs. You can console log, you can print this log right here, monitoring, pipe, timestamp, pipe, value, pipe, your metric type. pipe, your actual useful metric name, pipe, and then a tag. So you can use your tags here, very useful in Datadog, something that makes it very powerful. So you can split it exactly how you want it. You want to use business department, application, you want to use service, that's fine. All of those are available. Now we do collect CloudWatch metrics as well. So we have Lambda metrics here. We actually grab those step functions metrics as well. So you can see the success fail right there. But why don't you want that? Why isn't that okay? Is that all you need? Well, I'm pretty sure not many of you are actually in the business of lambdas, and you're not in the business of step functions. You want something that actually makes sense to you when you look at a graph or when you get alerted at 3 in the morning. You want to know, okay, because this lambda failed, I now have 500 people that couldn't complete their shopping cart trip, or I have 500 transactions on this specific part of my site that failed, that I can't do anything about. So you want something specific like that so that it's actually actionable, so that you actually feel it. It's not just some strange lambda or strange step function error over there. And that's why we would want you to use those custom metrics. Okay, so what we've done here today, we've gone through some basic Lambda stuff, and you now know that Lambda's definitely serverless, except for when it's not. But you know that it's serverless as far as you're concerned. You also know that step functions can really help orchestrate now. It's going to help you visualize it. It's going to help you organize it. It's really going to help you use those Lambdas in a new and fun and different way. And then finally, we went through a brief demo and showed you what those states look like in real life. And then we went to some monitoring talk. So that's what we've done today. If you have any questions, feel free to ask me. If you can't think of them now or you come up with them later, feel free to see me outside at the Datadog booth, or you can go ahead and reach out to me on Twitter at AlexTPoe, or shoot me an email at alex.poe@datadoghq.com. Thank you guys very much, and enjoy lunch.